college algebra, you know, maybe a couple of semesters ago. There's maybe some things you've forgotten, maybe some things that you remember. Okay, first thing is calculus is all built around the idea of a function. And what calculus tends to do is it takes a very general special case, and it can break it down to something more specific. For instance, in geometry, if you're a geometry student in high school, you learn how to find areas of special things, triangles, circles, special things. In calculus, you can find the area of just about anything you want to, you know, like a blob or something like that. You can find volumes of strange shaped stuff. So basically, a lot of times people say calculus is kind of the mathematics of infinity. We have the ability to break things up and get precise answers, and I mean precise, to just unusual things. So it kind of expands from the special case to the more general, okay? And that's what you'll kind of see as we go through. Now, since we talk about functions, the first thing I want to remind you of is what a function is. So this is a pretty good little diagram right here. You have an equation. X is usually like an independent variable. Okay, that's going to represent something like, oh, you guys can't even see what I'm doing. Okay, so that's not good. See, I was afraid this thing was going to fall out. Okay, can you see it okay now? Okay, all right, because this thing is done. Okay, let me know if that happens again. Do I need to dim the lights or anything? Okay, let's try this. Let's see if this works. And you tell me if this is better. Is that better? Nobody's saying anything. Is it better? You want to do it that way? Okay. All right, let's try that way because you guys need to see what I'm doing here. Okay, so what we have an independent variable like we have here, and then y is your dependent variable. What this example is saying is like x is the number of cars washed, okay, and then y is representing the amount of money raised. So the amount of money raised depends on how many cars are washed. So you have a dependent and you have an independent variable like that. Now, what a function is, what's special about it is every value of x, it can only give you one value of y, okay? Every value has a unique y value like this. So one thing you probably did in college algebra is you did function diagrams. You can tell me if you remember this. So here's some inputs. Here's x, 1, 2, 3, 4. Here's your outputs, a, b, c, d. The idea is the 1 goes to one y variable like that. The 2 goes to a. 3 to d, 4 to b. That's what a function looks like. Every x has exactly one y. You guys remember anything about that? Functions are huge in calculus. Okay, a couple other things is the domain. Okay, what the domain is that's just everything that x can be, everything that the independent variable can be. And then the range is everything the dependent variable can be. It's everything y can be. Usually x and y. Y is the range, x is the domain. Okay, here's a couple of other things we have like this. So if you look at this diagram right here, is that a function, yes or no? Yes. What question do you ask yourself? Does every x have exactly one y? Is that the case? It is, so that's yes. Okay, so you got a yes on that one. How about the next example? How about that? Yes or no? No. What's causing the problem? The 15 is causing the problem. Okay, the idea is the 15 actually has a y value of 7 and it has a y value of 9. So it's not a function. You can't have an x that has two y values. So that is not a function. That violates the basic rule. Okay? In higher mathematics, we get away from numbers, and functions don't have to be numbers. They can be people, shapes, whatever. How about this one? Is that a function? Yeah. Okay. Do you guys recognize those names? The Brady Bunch. That's the perfect function. Okay, let's use that example. Okay, now check this out. All right. Now draw these arrows like this because I want you to do this. Okay, say for instance you have people like this. Is that a function? No. Okay, because Ralph is 3-timing. Okay, he's got 3 girlfriends, so that's not a function. You can't do that. No two-timing. Ralph can only have one girlfriend. Okay, does that make sense to everybody? Okay. Okay, let's see what we remember on this. Okay, how about number 2? Is that a function? Yes or no? I'm curious. No. How come? You have a vertical line test. Okay, so one thing that you would have learned in college algebra probably is something called the vertical line test, and it's a simple way to tell if something's a function. The idea with this is if you took a vertical line, it goes through 2 different points. Okay, so it's kind of like, say for instance the x value of this point is 2, and say for instance that's 4. Okay, this would be like the same x, but it might have a different value. I'm just making up those numbers, but the point is the same x value cannot have 2 different y values. And that's what the vertical line test does, so that would not be a function. Does that make sense? Okay, a lot of times students have no trouble doing the vertical line test, but don't understand why it works. Okay, how about number 3? Is that a function? It is. Okay, the reason is because every vertical line you can possibly draw goes through 1 point. So yes, that is going to be a function. Okay, all right, does that make sense? Okay. Okay, now we're going to do just some algebra of functions next. It turns out that composition of functions really is a big topic in calculus. One of the reasons we spend time talking about that in college algebra is because to prepare students who are going to calculus. If you didn't know what composition of functions is, that's going to bother you when we learn something called the chain rule in calculus. That's just one example. So usually you see this notational system. You have that little open circle, kind of looks like it spells the word fog. That means F composed of G, okay, in that order. If you see it written this way, it means the same thing. So F of G of X is the same thing as F composed of G. So what I want you to write down is first write that notation down. Anytime you see that, you are composing a function. And what that means is you take what G of X is and you plug it into F. You kind of work from right to left when we do this. So here's how you do this. First of all, start by doing this. You're going to plug G into F. So what you do is you write down 4 times something. I put a blank where X is, plus 14. Okay, now what goes in that parenthesis in this problem from your background? The other function, the whole function. So see, that thing plugs in there. So you're plugging a function into a function like that. That's what composition of functions is. It creates a new function. Then you work it out with some basic algebra. So that's going to be 20x minus 4 plus 14. So that's going to give an answer of 20x plus 10 like that. That's composition of functions. That's how that works out. Okay, but you got to plug it in the right order. So you got to do that. Okay, the next one we're doing G composed of f of x. Okay, so you're plugging f into G. So the first thing that you want to do is you want to write down G. Okay, G is given by 7x to the 6th. Okay, so what you do is you write down 7 and then put a space and put a 6th power. Okay, now what do you plug into the parentheses then? 1 over x, right. Okay, so the 1 over x plugs in like that, and then you work it out, you know, using whatever basic algebra you can. So you got to remember the order you plug them in, okay? You kind of plug the right one into the left one like that. If you did this, you would have, really this is saying 1 to the 6th over x to the 6th. If you do a fraction to a power, you do the top and bottom of that power. What's 1 to the 6th? 1, because if you multiply 1 out 6 times, you get 1. So you would have 7 over x to the 6th would be the answer to that problem, because you're just multiplying the fraction straight across like that. Okay? So there's going to be one thing that happens in calculus, and by the end of this semester, one thing you guys are going to notice is you're going to be way, way, way better at algebra. Students really don't learn algebra real well until they take a calculus class. Okay, by the end of the semester, you'll be a king of algebra. It's a big, big part of calculus. And so you got some weaknesses. Believe me, you're going to get strong on them. Okay. Okay, let's look at one more composition of functions. Now, what's different about this one is now we have three functions, f, g, and h. So in calculus, we usually use f, g, and h, okay, just numerically to represent functions. This is the most common way. So if we do this, okay, it's kind of written this way, so it can be a little bit confusing the way you do that. So here's the way that I would do this problem. The first thing I'm going to do is you basically do it like this. You plug h into g, then you plug that result into f. So you got to go from the right to the left. The way I would approach this problem is like this. Step one is write down that function. Just write it down, but put a big blank where x goes. Okay? So what you got to, ultimately you're going to have a square root of something. Okay? Now what I'm going to do next is I'm going to write down g, and g is something over 4. So I've plugged that in. Okay, see what I did is I replaced x over 4, whoops, sometimes it does that, like that. Okay, now the final thing is, what do I put in that parenthesis right there? The last function, 4x plus 16. So let me write it like this, okay? So you want to write like 4x plus 16 over 4 like that. So what I'm doing is I'm plugging h into g, and then that result gets plugged into f. Does that make sense? Okay, just kind of substituting. Now we can simplify this, so let's see if you guys would know how to simplify this expression from your algebraic background. Okay, from your algebra background, what can you do with an expression 4x plus 16? Factor. You can factor a 4 out. Okay, let's do that. Okay, so you want to go ahead and factor the 4 out so that you have 4 times x plus 4. Okay, now what? Cross out the 4's. Okay, that's gone. So it looks like the answer to the problem is square root of x plus 4 would be like that. Okay, so one of the things I want you to do on your first assignment is practice, a few examples with composition of functions, because it will show up throughout the calculus class. Okay, it shows up in higher math, all the calculus classes. It's very important. Okay, do you guys got any questions about composition of functions then? Okay, so let's do just kind of one example where we have to evaluate this. So this problem, again, you got to know the language. If you're doing g of f of negative 2, the first thing to do on this problem is to do f of negative 2. So what I'm going to do is I'm going to write down f of x over here at the side. So this is a super important thing in calculus. You do it all the time. How do you do f of negative 2? There's nothing to it. What do? You plug negative 2 into x. Right, this thing right here goes there, so you're just evaluating the function. So you work that out. That would be negative 6 minus 3, so that's negative 9. Okay, so what that means is, that's what this is. That's negative 9. Okay, so we've got the answer to f of negative 2. Okay, now you got to evaluate for g. Okay, so g is this function. So just write it down, but leave like parentheses where your x's go. So you're going to have negative 5 times something squared plus 3 times something minus 1. And then what do you plug into those parentheses? Negative 9. The result, negative 9. And then you work that out. Okay, like that. Okay? All right, so you're kind of going right to left. So this would give negative 5 times 81. Minus 27 minus 1, then we can do that then, okay? Now one thing I like to use is screen, because I can use my calculator. I use my calculator a lot for showing graphs and calculus concepts. So I can go negative 5 times 81, that's a pretty big number. So that's negative 405, and minus 27 minus 1, so I'll just do that all in a couple steps on the calculator. So the final answer is negative 433. Okay, so that's kind of the primary part of composition of functions that you want to know how to do. Okay? All right, any clarification needed on that? You guys got a decent enough background for that? Okay? Okay, now here's the thing that students oftentimes struggle in college algebra. So I'm going to do these last couple of problems, and it's called a difference quotient, okay? And you can tell me in college algebra if you remember ever learning about that thing. Does that even look familiar? Okay. One of the reasons that college algebra teachers have you do that is because in calculus, that is huge. I mean, that's like one of the biggest things in calculus. We're going to learn that pretty simple, what a difference quotient is. In college algebra, no one explains what it is because you're not quite ready for what that is really doing. So this is kind of a big deal algebraically. You're going to do this a lot in this class. So we're going to take a function and we're going to evaluate the difference quotient. So what I want you to do first of all is just write down f of x plus h minus f of x over h, and watch this carefully because it's very common for students to have issues getting these problems set up. Now here's what I try to do to kind of help students with that problem. Okay, what you're going to have is you go ahead and you draw a big fraction, put h there, put a minus sign, put a bracket there, and put a bracket there. Okay, anytime you do a difference quotient, seriously, start that way. Bracket minus bracket over h. And follow it very, very carefully. Okay, f of x is this. What is f of x? What did I give you? 7x minus 4. So that goes there. That's it. Okay, just do what the problem tells you to do. Now, you do f of x plus h. What do you think f of x plus h means? Replace x with x plus h. Exactly. So see, you write the same thing down, but the only difference is, instead of putting x, what do you put? X plus h. Students oftentimes struggle with seeing that for whatever reason, so over many years of teaching this, I've always tried the approach of just put f of x there, so you just put what I give you, and over here all you do is replace x with x plus h. That's it. Now what we're going to do is algebraically simplify this and then see what we're left with, what result we're left with. So when we do this, you're going to have 7x plus 7h. I'm just doing a distributive property there, and then minus 4. Basic, just kind of basic algebra. Okay, I still see this in calculus all the time, students making mistakes. If you have a negative in front of parentheses, what does that do? Changes signs. You're doing subtract 7x, and see what you're really doing is subtracting a negative, and you've learned that subtracting a negative is adding, right? So that becomes plus 4 over h like that. Okay, look at the numerator. What happens? Got some stuff canceling out, right? Cancel them out. Okay, 7x goes to 0, 4 goes to 0. You're left with 7h over h, and then the h's divide out, so you get 7. And by the way, when you're doing a difference quotient, ultimately that h is going to drop out at the end of the problem. If it doesn't drop out at the end of the problem, something's going wrong. So that's the idea. All right? So I'm only going to do this part of the problem. I'm not going to do the f of x minus f of a on all these problems. I'll do it on some of these, on the next one then. Okay? Is there any question about how that problem was worked out, how I set it up? Okay, we're going to do one more, and this one's a little bit harder algebraically. And one of the things when you're learning calculus, when we start learning the idea of a derivative, we do it with a difference quotient, and sometimes it can become a really messy algebra problem, but ultimately we get away from that. So start this problem this way. First of all, write down what you're doing. You're doing f of x plus h minus f of x all over h. Okay, and this is what you want to do. Make a real super big fraction. Put like a bracket or a parenthesis there, a smaller one there, and then put a real super big bracket like that. Before you get your difference quotient put up, I'm serious, build the framework. Okay? Now, what goes here in what I'm highlighting? F of x. What is f of x? It's this. Okay? So just put it in the parentheses like that. Don't change it. Just do that. So that's step one, is just get f of x in there. Now, what's going to be the difference between this bracket? What's the only difference? Exactly. The x's are going to change into x plus h. So when you go to this one, write everything the same. Write 5 times something squared plus 6 times something minus 2. And then what you want to do there is you want to put in x plus h. Okay, that's what's different. So I think, that should help students. See, that's what I gave you. It's the same thing except that. Okay, does that make sense? Okay, look at the problems that way, because it's very, very common for students to struggle when they learn this, getting everything set up. Now we're going to do a bunch of algebra. Okay, so a little bit more work involved on this one. So what I'm going to do is I'm going to start with this thing. Okay, we can do, if you do x plus h squared, one way to do that is just to write it out twice, and you've probably learned, FOIL from your background. You can do that. Some of you may know how to do that in your head. If you run through the FOIL on here, you're going to get x squared plus xh, and that's hx, but I'm just going to write it as xh, and then h times h is h squared, and then these two things are like terms. So what you're going to get, the result of x plus h squared, I'm going to put as x squared plus 2xh, again, because those are like terms, plus h squared, and then I still got the 5 in front of that, like that. Okay? One thing that you want to do the higher you get in math, the better you want to get. You want to get to a point where you can learn how to do this in your head. And many of you may know how to do this. What you do is you square the first term. So what you do is you just take x squared. You square the h. That's h squared. Now, a lot of times students stop there. The other thing you do is you take x times h, then you double it. That's the shortcut. You can learn to do that real fast. And the higher you get in math, the more important it becomes to just do some kind of the shortcuts like that. Saves you a little time. Okay, now let's move on. We've got that done. Now we're going to do distributive properties. So that's 6x plus 6h, okay, like that. Then we have minus 2. We don't really need these brackets anymore. And again, the minus sign, the subtraction symbol, is going to change these signs. So you're going to get subtract 5x squared, subtract 6x, and add 2 like that. Okay? Any questions? Foiling, distributive property, basic algebra stuff. Okay, now I'm going to do this. I'm going to distribute this. So I'm going to get 5x squared plus 10xh plus 5h to the second plus 6x plus 6h minus 2 minus 5x to the second minus 6x plus 2 all over h like this. And see, I'm writing things real methodically. That's the way I expect you to do things, is do everything. You can do a few things in your head. I don't mind you doing that, but the better you keep things together, the more accurate you're going to be. Now, what do you notice happening in the numerator? A lot of canceling, isn't there? It happens all the time on these problems. So let's see. 5x squared cancels. What else? 6x. What else? The 2's. Now, what I want to point your attention to is what's left over has an h in it. That's real critical. And what happens is you can factor that h out of what's left. So right now you've got 10xh plus 5h squared plus 6h. So just take an h out of it. Don't take any other factor out, just that. So that's going to leave you 10x plus 5h plus 6, and then all over h, and then what happens? H cancels out. Like I said, it's always going to. As you're doing these problems, that's going to be your last step. Okay? It's going to cancel out. There's going to be some factoring involved, and then you're ready to write your final answer. Okay? Now, we're going to learn the significance of this thing in a couple of weeks. Probably next week we start actually learning what the difference quotient is and what the importance to calculus is. But it's a great algebra exercise. You'll have a little bit of this on your homework, and that'll prepare you for some things we're going to do next week. Okay, any questions about anything going on so far? Okay, hardest thing I've taught you so far today is the difference quotient. All this stuff, I just kind of picked out key areas that you want to be sure that you know how to do.